Kessler syndrome is a terrifying chain reaction because it's one of those things that sounds like science fiction but is hitting us right in the face. Orbitally speaking, where space junk starts smashing into more space junk, creating an unstoppable debris storm that could lock us out of key orbits forever. You have probably heard whispers about it, but how close are we really? The Kessler syndrome was first conjectured back in 1978 by NASA scientist Donald Kessler, and astronomers and space enthusiasts have been worrying about it ever since. Kessler basically said that once there is too much stuff circling in low Earth orbit, LEOs, some of it will inevitably fall apart and create debris that will uncontrollably splatter into unknown orbits. And this sparks a cascade where debris gets increasingly smaller and eventually distributes around the entire globe. In the past couple of years, we have seen a spike in satellite breaking up and near misses with space debris. For instance, in June, a defunct Russian satellite broke up into more than 100 pieces of debris. In August, a Chinese rocket broke up upon launch, leaving behind more than 250 pieces in the orbit. But that's just the tip of iceberg from the recent months, and things haven't slowed down. Remember the Shenzhou 20 incident? A few months back in 2025, one of the Chinese capsule was struck by a piece of completely unanticipated space debris. We can never really predict when something like this happens. Now let's talk numbers because the stats are jaw-dropping. The European Space Agency ESA estimates there are more than 100 million pieces of debris in low Earth orbit already, and that could be over 130 million based on the latest 2025 report. While most of them are smaller than 1 centimeter in diameter, about a million are between 1 and 10 centimeter, and about 40,000 are larger than that. The total mass of more than 13,000 metric tons, about twice the weight of the Eiffel Tower, or per some updates, over 6,600 tons just in the LEO alone. But the scariest part is that these space debris isn't just its trash floating around, or that it will have an environmental impact. The real problem is the speed of that debris, tens of thousands of miles an hour, and the possibility that said debris will impact other valuable objects in the orbit. Now imagine two fragile 1,000-pound objects colliding at hypersonic velocities. That creates a massive debris cloud where every stray solar panel or screw could obliterate another spacecraft. And yeah, orbital collisions have already happened. The first accidental one in 2009 between US and Russian communication satellites, spawning a huge debris cloud. If the Kessler syndrome becomes reality, it might mean we simply can't put any more satellites into these orbits. If space flight stopped for the next 200 years, we would still see runaway debris growth per NASA visuals. And up until recently, we never really had stories like this. But in just the last 2 years, there's been now quite a few reports of basically random space trash being discovered in some of the most bizarre locations. Here's one from the Kenyan village, and here's the one from the Australia. Adding to that, in 2025, we had a SpaceX Starship IFT-7 test where debris rained down dramatically. Luckily, no injuries, but it's a vivid reminder. As of early 2026, pretty much every single day, at least two satellites pass very close to each other every 22 seconds within less than 1 kilometer. Let that sink in. Every 22 seconds, three times a minute, satellites are dodging within a kilometer. To keep things running smoothly and avoid collisions, satellites have to move constantly. On average, each Starlink satellite performs 41 maneuvers per year, just to avoid running into other objects, showing predictions aren't foolproof. And this classic Kessler problem is a bit of a slow burn. It may take decades or centuries or happen suddenly all at once. That's the proposition in recent studies. A sudden explosion or increase in particles out of nowhere for reasons no one can control. Shout out to Shara Thale and her team. Their paper, An Orbital House of Cards, frequent mega constellation close encounters raise collision risk, just dropped in December 2025. They introduce a metric called crash, collision realization and significant harm. The crash clock measures how long it would take for a catastrophic collision if satellite operators suddenly lost the ability to send avoidance commands, like if Starlink goes offline or SpaceX goes bankrupt and leaves satellite orbiting. How long before the collisions spike? It's a test of how fragile our orbital environment is, and the results are staggering. In 2018, before mega constellations explode, the crash clock was about 121 days. If we lost control, it would likely to take that long for collision, giving time to recover. But as of June 2025, it plumped to just 2.8 days. Scientists and engineers proposed some ways: sweeping orbits to collect junk, dumping into atmosphere to burn, laser debris into new orbits for avoidance or re-entry. This is based on 2025 data, with more satellites from Amazon, Chinese companies and others. That 2.8 days could shrink to hours soon, assuming current launch rates of about 1500 satellites per year. We have less than 3 days to fix things if maneuvering system disconnect. If operators lose control for even 24 hours, there is 30% chance of at least one collision, and single event could speed a decade long Kessler process where each particle smashes something else, creating more debris. So, how close are we?